Well, Math 151, let's have an example 2 for the quotient rule. Suppose I have y equal cotangent of x over 1 plus cotangent of x. So notice that what I have is y equals some f of x over g of x. And so y prime of x is going to be derivative of top f prime of x times g of x minus the top untouched times g prime of x all over g of x to the second power. You can also rewrite this as y prime equal g of x times f prime of x minus f of x times g prime of x all over g of x to the second power. Notice that here we do have multiplication, so it doesn't matter which one do you write first, and same thing for here. Okay, let's go to the next page and continue with our example. So I have y equals cotangent of x over 1 plus cotangent of x. So y prime equals, let me try to write smaller so I don't get out of the page. The derivative of top is derivative of cotangent of x is minus cosecant squared of x times 1 plus cotangent of x, then minus the top untouched times the derivative of the denominator. The derivative of 1 is 0. The derivative of cotangent of x is minus cosecant squared of x all over 1 plus cotangent of x to the second power. Let me change colors, so y prime equals, and so here I do have minus cosecant squared of x minus cotangent of x cosecant squared of x, and then we have plus cotangent of x cosecant squared of x all over 1 plus cotangent of x to the second power. Let's see, I can cancel this 2, and I'm left with minus cosecant squared of x all over 1 plus cotangent of x to the second power. We don't need to simplify this more, anymore. Let's do another one. Suppose y equals cosine of x over 1 plus sine of x. So y prime equals derivative of top, which is minus sine of x times 1 plus sine of x times, or minus the top untouched times 1 plus sine of x. Derivative of 1 is 0. Derivative of sine of x is cosine of x all over 1 plus sine of x to the second power. So y prime equals minus sine of x minus sine squared of x, and then I have minus cosine squared of x all over 1 plus sine of x to the second power. Oh, this is nice. Y prime equals minus sine of x, and then if I factor a -1 Then I get sine squared of x plus cosine squared of x. And of course, that's a 1 over 1 plus sine of x quantity squared. And so we know this is a 1. So I'm left with minus sine of x minus 1. Let me go to the next page. So y prime equals minus sine of x minus 1 over 1 plus sine of x quantity squared. So that equals minus sine of x plus 1 over, notice I can rewrite the denominator as sine of x plus 1 to the second power. So this equals negative 1 over sine of x plus 1. Okay, let's do one more. How about something like y equals 4 over cosine of x plus 1 over tangent of x. Okay, I kind of recognize this one. You know, I can rewrite this one as y equals 4 secant of x, and 1 over tangent of x is cotangent of x, plus cotangent of x. So y prime equals 4 secant x tangent x minus cosecant squared of x. Okay, but what if I didn't recognize this? And if I did use the quotient rule, would this give me the same answer? So let's keep this and go to the next page and just use the quotient rule, like pretending that we didn't see the pattern. So y equals 4 over cosine of x plus 1 over tangent of x. So y prime equals derivative of top, which is 0, derivative of 4 is 0, times the denominator cosine of x minus the top untouched times derivative of the denominator, which is minus sine of x, all over cosine of x to the second power. And so I have plus derivative of top, which is 0 times tangent of x, minus 1 untouched times derivative of tangent is secant squared of x, all over tangent of x to the second power. So y prime equals, well, 0 times cosine of x is just 0. Then I get 4 sine of x over cosine squared of x. And then I have, this is 0. So I have minus, or I should say plus minus secant squared of x over tangent squared of x. And let's simplify this. So this is y prime equals, here's my 4. In the denominator, I have cosine times cosine, so I can rewrite that as sine over cosine as of tangent of x, and then secant of x, minus, let's see, 1 over cosine squared of x, 1 over cosine squared of x for my secant squared, and then 1 over tangent, which is cotangent, rewrite that as cosine squared of x over sine squared of x. Okay. And notice that I can cancel this with this, and 1 over sine squared is cosecant squared. So let's go to the next page and finally clean it up. Y prime equals 4 tangent of x, secant of x, tangent of x times secant of x minus cosecant squared of x. And let's see, was this the same as our previous answer? In this page, yep, for secant x, tangent x, minus cosecant squared of x, with the exception that on, our other answer was y prime equal 4 tangent of x, secant of x, which is the same thing as this, minus cosecant squared of x. Okay, thanks.